As we start chapter 2, we're starting off easy. And a little quick review is when we have our coordinate plane, there are 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we use Roman numeral numbers for this. And if you recall from our lesson, we said that the ordered pair here, both were positive. Here the x was negative and the y was positive. Here they were both negative. And here the x was positive, but the y was negative here. Let's get a proper negative sign there. And so in looking at our first example, they're both negative, so which quadrant would that be? Well, that would be the third quadrant. And remember, if either of the x or y values were 0, then it would be on an axis. So a general review of this. Now, for example 2, in the practice, they gave a horizontal t-chart. I like to make a vertical one. So there's your x value, y value, and then just fill it in. Here we want a 0. Here we want a 0. So these will give us our intercepts. Here the x is a 3 and the y is a 4. So I'll do it vertically and you can do it, put your answers in horizontally or either way. So if y is a 0 here, negative 8 times 0 is 0. Just divide both sides by 12. You get x is a 1. And again, hopefully pausing and you're trying these out first, then I'll do them. Now, if x is a 0 here, this is a 0, 12 times 0 is 0, we're going to get a 12 divided by a negative 8, which reduces to a negative 3/2. Now here, if our x value is a 3, this is going to become 12 times 3 is 36 minus 8y equals 12. So we're going to subtract 36 from both sides. Oh, this is actually a negative 36. So we're going to add, now you have to be careful, check your work, add 36 to both sides. We get a negative 8 equals 48. Then divide both sides by a negative 8. And we get y then for this one equals a negative 6. Now again, if y is 4, this will be 12x. Negative 8 times 4 is a negative 32 equals 12. So we're going to add 32 to both sides, or just transpose that. That becomes 44. And then divide everything by 12. And we can take a 4 out of each one, so this is 11/3. Now, if you think I'm doing these quickly, I had worked them out before. So, I've studied them, I've looked at it, and I've mentally checked this. Now, as I look through the practice, there are a couple of examples similar to this, where they gave you these 3 points of a triangle, and they wanted you to find the perimeter. So what I did is I put this graph here. This wasn't with the problem originally, but again, to give you some idea of strategies. So let's plot these 3 points here. So our first point is a -3, -15. Now that's going to be off the graph, but that's going to be here for line 3, about there here. So that's a -3, -15. Now the next point is 9, 2. So that's on the graph. We go 9, or I should say 9, 1, which is right there. And then we go and find our third point, which is -3, 10. Well, we already had a -3 down there, and then a -3, 10 is right up here. So I'm going to use my line tool to draw these. So I went off a little bit, but this is a straight line. And then from here to there, and then from there to there. All right, so there's my triangle. So you can see that all sides are different. So this is what is called a scalene triangle. If 2 sides were the same, that would be isosceles triangle. And if all 3 sides were the same, that would be, I believe, equilateral. Okay, a little bit of geometry here. Now, since this is a straight line, we don't have to use the distance formula to measure this. We could just count the number of units. So there's 20, and then 5 more. This side is 25. So that saved you from using one of the distance formulas to figure out these. They're rather tedious and take a while. So what is the distance formula? Well, distance equals the square root of x squared minus, I should say x sub 2 minus x sub 1, the quantity squared, plus, and then it's y sub 2 minus y sub 1, the quantity squared. So we have done this one already, where we've taken this one and this one. So now we have to take this one and this one. And let's pause as you do it, and let's see what you get, and I'll do it as well. Okay, so I'm using this as my x sub 2. So -3, -9. Because the formula is negative. So this gives me a -12 that I square, becomes positive. And this is 144. And then this is 10 minus 1 is 9 that I square, which is 81. 144 plus 81 is 225, and that's a perfect square. So this side then is going to be 15. And that is kind of straightforward. All right, now do the next one. You don't have to write this formula again. Just put the substitution in there, see what you get, and let's check it out. So again, our -3 minus 9 And then for our y values, a negative 15 minus 1. So this will end up being a negative 12 that we're squaring, which makes it, in a sense, a positive 12 that we're squaring. And this is 144, and added to this gives you 400. And the square root of 400 is 20. So this side is 20. Oh. So we have 15 and 25 is 40, and 20 is 60. So the perimeter of this is 60, whatever units this is. Okay, so again, rather tedious because you had to, if you didn't make a picture and see that these were lined up, although you notice you have a negative 3 and a negative 3, that sort of indicates you had a straight line, but it's good to see it and know what is expected when you get an example like this. Now, for this one, I made it a little bigger, and again, they didn't give me the graph. I had to put that there myself. But let's take a look at this, because they want you to determine whether or not these given points form a right triangle, and if the triangle is not a right triangle, is it a isosceles where two sides would be equal, or a scalene where no sides would be the same? So you could put all of these in the distance formula, but that's a lot of work. But let's just sketch it and see what we get. 6, 3. So 6, 3 is right there. 4, 9. So 4, 9. Let's see here. Count up 9 here. Let's see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, right there. And then 8, 9. Well, there's 6, 7, 8, and this is going to be right there. So let's make our lines. So what do you think? Well, these two sides are the same. This side is definitely shorter, so this is going to be an isosceles triangle. Now again, if you figured out this distance and this distance, those distances would be the same. This would not be the same. And as you see, this is not a right triangle. So we gave you using the distance formula, and we're giving you now using something visual. So again, you can sort of sketch this and put the points here. Some of these are going to take time, and hopefully we're giving you some useful strategies. Now, as we look at example 6, what are they asking? Determine the distance between the 2 points. So this is straightforward for distance. So let's just put that together here. So let's use this as x sub 2. That'll be 5 minus 2, the quantity squared, plus negative 10 minus 7, the quantity squared. All right, take some time, do some figuring, and see what you get. So something like this, 5 minus 2 is 3, 3 squared is 9. Negative 10 and negative 7 are negative 17 squared is 289. If we add these together, take the square root of it, this would be the exact answer of the distance. And then if I put that in my calculator and round it off, it's not a perfect square, to 4 decimal places, this is what I get. But I'm assuming they will accept the square root of 298. Now, what we're going to do on this example, because this was actually in 2 parts, is what would be the midpoint then, the coordinates of the midpoint of this line. We didn't do that one, so let's do one like that. Now, the formula for the midpoint is x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. So we got 2 plus 5 is 7. 2 plus 5 divided by 2 is 7/2. And then here we have a 7 minus 10 is a -3 divided by 2. So this would be the ordered pair of the midpoint of this line. For example 7, now we have a quadratic equation, which would be a parabola. It's going to open up downwards. It would look like so. And then they're asking us to find some points along this. So how do we do it? Well, again, they're asking for a T-chart that's horizontal. I like it vertical. I put in the values, and you can take a moment to copy this down as well. So if x, or I should say y, is 0 here, this y is 0, we have a quadratic equation where we need to solve this for the x values. This factors nicely, and we'll do some factoring a little later on too, or we reviewed it, I guess, already. So this is going to be 3 and 3, and both of these are negative. And the protocol is we equate each of these to 0. This one is equal to 0, and so is this one. And you're going to get 2 answers in which x is a +3. Okay. Now this one's easy. When x is 0 here, this is going to be, let's clear this up here too. X is 0 here, and this x is 0, so y is going to equal 9. Now how about if y is 1? So let's put a 1 there. And to solve it, we have to, again, get this side to equal 0. We're going to transpose that 1, and we get x squared minus 6x plus 8. Now this still factors here, and I want to put that 0 over there, not there. And we're going to use 2 sets of parentheses. And this is an x and an x, and this is a 4 and a 2. And both of these are going to be negative. If we FOIL it, it checks. We equal each of them to 0. This one to 0, this one to 0. Here we get x is a +2, and here x is a +4. Now they're saying here if there are multiple solutions, you only need to list one. So either one. We're going to say it's 2 or 4 when y is 1. And again, we're getting some points to make our parabola if they're asking us to eventually graph it. Okay, so the next few are kind of easy. Let's clear this up again here. because now we're going to replace our x with a 5. So it's going to be y equals 5 squared minus 6 times 5 plus 9. Well, this is 25, and 9 is 34 minus 30. We end up with a 4. Once again, this is 25 and 9. This would be 34 minus 30 gives us a 4. So we're going to do the same thing now, and I'll do it down here. And you should give it a try. What would you get if x were 2? Well, again, we're solving the same kind of thing. 2 squared minus 6 times 2 plus 9. Well, this is 4. This is a negative 12 plus 9. 4 and 9 are 13. Minus 12 is a 1. So when x is 2, y is 1. Okay, that wraps this up. Ran about 22 minutes. Not too bad. Again, we paused it. You know, when you do this certify, and you might try some practice first, they're going to be challenging. You need to be careful of your work, double check it, watch the signs. All right.